Hi class, welcome to our lesson on isosceles triangles. It's from chapter 4, section 6 here for today. We've certainly talked about what an isosceles triangle is, two sides that are congruent lengths. But now we're going to go more into detail on isosceles triangles and talk about more properties about isosceles triangles. Let's quickly just refresh what an isosceles triangle is, and let's label every part of an isosceles triangle. There are 6 parts of a triangle, 3 sides, 3 angles. The sides, the two congruent lengths, those are called the legs of an isosceles triangle. Okay, so the two congruent sides, we call those legs, and then the third side we call the base. So this side right here that I'm lining in green, this is called the base of the isosceles triangle. It's very tempting to think that the base is always at the bottom, because those two words can sometimes be synonymous with each other. In math, that's not the case. I could have an isosceles triangle, something like this, and if these two sides are congruent, now if I have an isosceles triangle that looks like this, for example, now these are the two congruent sides, so those are the legs, and this one right here is the base. So don't get in the habit of always thinking that the base is the lowest part of the triangle. The legs are the congruent ones, and the third side is called the base. The base angles right here, those are the two angles that are by the base, that side, and then the vertex angle, this one right here, the vertex angle is made by the two legs, the two congruent sides. So those are the parts of the isosceles triangle. Okay, so if the green is true, then the red is true. This is a conditional statement. And so we're saying if two sides of a triangle are congruent, which it is, this is an isosceles triangle, this side right here is congruent to this side right here. If that's true, then what can we say? What conclusion can we make with this hypothesis? Well, if you take a look at this sketchpad activity here, what I have is I have triangle ABC, and two sides are congruent. AB is congruent to AC. I know that because they're both radii of a circle, and every radius of a circle is congruent to every other radius in that same circle. So if I reveal the angle measures right here, the measure of angle B is 67 degrees, and the measure of angle C is 67 degrees. Watch what happens here as I move this around. Okay, the angles change. Now my angle C is 51, and what's my measure of angle B? It's also 51. So what's happening is no matter how I move this, my angles, the base angles, are always going to be congruent to each other. So that's what is the conclusion here for my conditional statement. If the two sides of a triangle are congruent, then the angles opposite those sides are congruent, which is the base angles. So notice where the location is. This side opposite is this angle right here. And of course this side opposite, those are the base angles, and those are congruent to each other if the sides are congruent to each other. The converse is also true. If we switch around the conditional statement, if two angles of a triangle are congruent, if this is, let's say, 35 degrees and this is 35 degrees, what can we say about their opposite sides? Well, if the base angles are congruent, then the sides opposite those angles are also congruent. So if this was 7 feet, then this would also have to be 7 feet, for example. If the sides are congruent, the base angles are congruent. If the base angles are congruent, the sides are congruent. That's one important property of isosceles triangles. So now if we think about equilateral triangles, as well as equiangular, equilateral means that all three sides are equal to each other. So this side is equal to this side is equal to this side. Now on our last slide, or a couple slides ago maybe, it said if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So that's what we see here in this equilateral triangle. If this length is congruent to this length, then the base angles are congruent to each other. Okay? And if this side is congruent to this side, then the sides opposite are also congruent to each other. And if this side is congruent to this side, then its opposite angles are congruent to each other. So what do we have with this big huge mess here? We just see that all the angles must be congruent if all the sides are congruent. If we have an equilateral triangle, then we must have an equiangular triangle because all three angles must be congruent because they're opposite congruent sides. And so what would all those angles be? There's 180 degrees in a triangle, so if we split it three ways, each one has to be 60 degrees. So that's the point of this slide, is to see that there's no such thing as an equilateral triangle unless it's also equiangular. There's no such thing as an equiangular triangle unless it's also equilateral. They are one and the same. An equilateral triangle is equiangular. Alright, we have two example problems here. This one deals with angles. So angles of an isosceles triangle, the base angles are congruent. So let's take a look at what our given information is and let's mark up our picture. DE, that segment, is congruent to segment CD. So those two lengths are congruent. What else do we know? BC, that segment BC, is congruent to segment AC. So those two are congruent. And then we also know that the measure of angle CDE is 120. So CDE, this angle right here, is 120 degrees. And our answer, find the measure of angle BAC. We are all done once we know how many degrees this angle is. Alright, well, if you could kind of talk this through with me, this green triangle is isosceles, isn't it? Because two sides are congruent to each other. The two legs, CD and DE, are congruent. So that means the side opposite, the angles opposite those congruent sides, those two base angles are congruent. So this angle is congruent to this angle. And I also have a red triangle right over here in triangle ABC. It's also isosceles because the two legs are congruent. So opposite those two legs are the base angles, which are also congruent. Alright, I've marked up our picture pretty well. Now, let's fill in all these angles. There's 180 degrees in a triangle. So in this green triangle over here, 180 degrees, but we got to subtract the vertex angle of 120. That means there's 60 degrees left. So angle C and angle E, there's 60 degrees between the two of them. So that means each of them has to be 30, right? If you divide 60 by 2, it equals 30 degrees. So now we know the measure of angle DCE is 30 degrees. And notice angle BCA is a vertical angle, and vertical angles are congruent, so that's also 30 degrees. So now in triangle ABC, there's 180 degrees in that triangle. Of course, every triangle has 180 degrees. And 30 of them are that vertex angle. So if we subtract 30, there's 150 degrees left of the triangle. And in an isosceles triangle, the base angles are congruent, so if we divide that by 2, if we cut it in half, that's the measure of each of those angles. So 150 divided by 2 is 75 degrees. Both base angles are 75. So our answer, angle BAC equals 75 degrees. Let's take a look at one more. This one, it says find the length of all three sides of the triangle. Now again, it's tempting for us to always kind of think of triangles with 180 degrees. And that's true with the angles, but the side lengths have nothing to do with 180. So don't add all three of them up and set it equal to 180. That's not the concept that we're dealing with. We're talking about the lengths or the sides of an isosceles triangle. We know it's isosceles because this angle is congruent to this angle, so we call those base angles. And opposite the base angles are the two congruent sides. So this length is congruent to this length. So the segments are equal to each other in an isosceles triangle. They are equal. So 3x plus 15 is the same length as 7x minus 29. We set the two congruent sides equal to each other. Now let's solve for x. Subtract 3x from both sides and add 29 to both sides. So we get 4x equals 15 plus 29 is 44. Divide both sides by 4 and we get x to equal 11. So if we know x equals 11, our instructions say find the length of all three sides. So one of the lengths is 3 times x plus 15. Another length is 7 times x minus 29. And the third length is 5 times x plus 4. And of course we found x to equal 11. So our three lengths are 3 times 11, 33 plus 15 is 48. Another side is 77 minus 29. 77 minus 29 is also 48, and that makes sense because those are the two legs of our isosceles triangle, which they should be congruent. And our last one is 55 plus 4 is 59. So we'll put units here. Usually they're like feet or inches or miles or kilometers or whatever the case might be. I didn't give you units on this one, so they're 48 units long, 48 units long, 59 units long. I hope isosceles triangles made sense. The biggest thing is that two legs are congruent, and the opposite those two legs are the base angles, which are also congruent. Let me know if there's any confusion about that when you get to class tomorrow.